All right, in the notes section of your workbook, you will notice that combustion reactions don't have their own page of notes. They are only combined with double displacement reactions. Reason being, there's not a whole lot going on here. They are really the simplest of the reaction types because we're going to assume perfect, clean combustion. So combustion is a reaction between a hydrocarbon and oxygen, and it always, and I mean always, produces carbon dioxide and water vapor. Okay, so it's always something with carbon and hydrogen. You can throw an oxygen in there. Plus oxygen gives you carbon dioxide and water vapor. I think it is ironic that one of the products of fire is water vapor. Actually, both these products will put fire out. If you somehow collect the carbon dioxide and the water and you can put fire out with them. I think that's an odd thing that's what's created by fire. Okay? The key to identifying is always going to be this, that you got the C, something with C and H plus oxygen. All right, so like I said, predicting products, it's really easy. It's always carbon dioxide and water. Carbon dioxide and water, carbon dioxide and water, carbon dioxide and water. Doesn't matter what you're reacting. If it's something with carbon and hydrogen plus oxygen, always going to be carbon and water. Carbon dioxide and water, always. Difficulty with these is balancing them. They can be tricky to balance because they're going to have the oxygen in two places on the right side. So just like we learned when we did balancing, you've got to do the oxygen last. So here, so CH4 plus 2O2. Okay, so one carbon, four hydrogens. Then I've got two oxygens plus two oxygens for a total of four oxygens. So I put a 2 there. So you can do that. And so, but it gets tricky, like not that one, but here. You can start getting some crazy big numbers. I don't know why this is offset somehow, but it is. But look at this. These are huge numbers. 2, 29, 20, and 18. That can be a little disconcerting when you start balancing some of these. You're like, wait, did I do something wrong? No. Just when you balance combustion reactions, sometimes you're going to get big numbers. It happens. Okay? So that's combustion. And combustion reactions are also going to be that one where, like, if you try to balance this one the first time, it's not going to work. And you're going to have to put a 2 in front of it to make it balance. And so that can also is a common problem with combustion reactions. All right, let's take a moment and review the different types of reactions. So we can identify the types by just simply looking at them. If it has one product, it's combination. One reactant, decomposition. Element plus a compound is single displacement. Compound plus a compound is double displacement. And then something with carbon and hydrogen plus oxygen is combustion. Okay? And each type has their own way of predicting the products. So this is where when you're predicting products, you have to identify what type of reaction it is first, just to be able to predict the product correctly. So for example, here's magnesium and sulfur. It's a combination reaction. So just use that information to give you the formula. So it's an element plus an element. That's combination. Single displacement. Remember, we got to use the activity series. And then we see if the reaction occurs. Then once again, we use the ionic charges to figure out the formulas. And then we balance. Same thing with double displacement. Predict the products. Use the ionic charges. Use solubility table to see whether a reaction occurs or not. If there's precipitate occurs, identify that precipitate, and that is your thing. And then finally, combustion, always, 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 carbon dioxide and water vapor, making life simple. So that is all of your reaction types together. And so that is the end of this unit, and we'll see you in calculations and measurements next.